Yeah, that's super cool. Makes sense. Yeah, so today we've got object-oriented programming features of Rust. This was this was kind of a weird chapter, I thought. I don't know about you guys. But the first part in particular, it was interesting to think about, particularly coming from R, which is also such an unusual object-oriented language, but also has its own kind of, style of doing it. It was interesting to think about, how you can use these ideas without being like fully OOP. So the three main parts of this chapter were considering whether or not Rust is actually an object-oriented programming language or not. Looking at how traits can fill in some gaps of some traditional OOP techniques. And then this was really the weird part of the chapter, I think, was implementing the idea of state with traits. But then I also have a version with enums because they suggested that we do that. And so I thought we could discuss briefly. So the first part really is Rust an OOP language? And I think they're being a little tongue in cheek about this because they certainly there are some influences from OOP ideas, but it's not like Python or Java or something that's got a little bit more traditional design. So they give us a few different things to consider and whether or not Rust fits into those ideas. And so the first one is objects contain data and behavior. So this is like an easy win for Rust because structs can contain data and we can implement functions for them. And then we've got enums as well. So even though structs and enums with methods aren't called objects, they provide the same functionality. So yeah, whenever I see something like this, I always sort of think about traditional object-oriented programming when we have data that we can add methods to. Encapsulation that hides implementation details. So if encapsulation is a required aspect for the language, then Rust meets this requirement too, because you can use the pub keyword to tell Rust whether or not to make public a part of a module or a piece of data. And then inheritance as a type system and as code sharing. If a language must have inheritance to be an object-oriented language, then Rust is not one. However, if you're used to having inheritance in your programming toolbox, you can use other solutions in Rust. This is one that it was, it feels a little bit like how R handles it. Like it's missing a lot. R is missing a lot of traditional OOP design as well. And I guess R is a little bit closer to having inheritance because there's like a stack of classes and it sort of seeks through those. But the way that it does dispatch feels similar in spirit to the way that traits do dispatch. And then similarly, polymorphism and inheritance. Rust instead uses generics to abstract over different possible types and trait bounds to impose constraints. So we saw that before. What I had never heard before was this term bounded parametric polymorphism. So very technical. didn't mean much to me. So traits, if you recall, I did the traits chapter as well, which was interesting. And I was already sort of thinking about this before I got to this chapter, about how traits can fill in some of the gaps in a more traditional approach to OOP. So I have a trait sound, and it has one function in it, which is make sound. And I have, I'm just remembering that I have a playground script for this that I didn't open yet. So I'll have to open that up in a second here. But I have a struct animal that takes something that makes a sound. And so it puts it in a box and it requires that it has the trait sound. So I create a new animal that has this sound, and when I call make sound on animal, it looks into that object that has in the box that has a sound trait that can do make sound. And so each one of these will be slightly different. And so, for instance, if I implemented a dog and implemented sound for dog, it would be function make sound woof. And then in my script, I have birds and cats as well. And now I can put together a vector of these animals that all are able to use this function because they have the sound trait implemented for them. So this is a little bit like inheritance, the way that this is working. We're putting a bounds on what can go into animal, and then we're doing things with it. But we're kind of like calling up from it the way that you might do with super in a traditional OOP language. So for this, I go one by one, and I say animal makes sense, and they go woof, meow, tweet. Hang on a second. Let me pull up the playground for this. I forgot that I had that. So woof, meow, tweet. So for each one of these, I implemented the sound trait for each of these animals, and so it was sort of like they were, we were putting restrictions on our code such that the animal struct requires that it accepts something that can make a sound, and so we're putting this restriction on the code that makes this relationships going upwards and downwards, even though it's not what you might traditionally think of as inheritance. Okay, so this is the this is the weird part. That was all pretty short because I think that the first two parts of this were pretty straightforward. Is it an OOP language? Kind of, but not really. But there's a lot that even the things that don't fit into the traditional OOP system, there's a lot that you can still do using traits and generics that I think we kind of saw before in that chapter. The third part was the weird part, which was using traits to implement state data. And so I thought we could talk about this example and go through what they did, and then I have a different implementation based on what they suggested that we try out. So this is the code that we want to be able to work. And so this is the same code that I will have the same code in the enums version. We want to be able to create a post and add text to it. And then, basically until it's been reviewed and approved, we don't want the content to come out of this content function, but we also don't want it to do, we don't need it to fail. We are just going to have it spit out, nothing, basically, just an empty string. So they have us do something very similar to what I had in the animal struct, which was that they have this they have two pieces of data in struct: content, which is the post itself, and then state. And so this is sort of like what I had before, but even weirder, because it's saying that you need something here that implements the state trait. And so the new implementation of new gives us a version of this that wraps a box around sum and has draft in it. So draft, I didn't even include it in this code because draft is just an empty struct at this point. So then we implement request review first for post, but then also for the trait state. So again, this is very similar to what I had before. We're going to have request review for post go into the state the thing that has the state trait and call request review on it. So that's what we're doing here. This is very similar to me making a dog woof inside of animal. So draft is still empty as the struct itself, but we're now implementing state for draft. So we need to do request review. So what this is we're doing is we're changing the state to pending review. So that is also an empty struct that also has state, that also has request review because it needs to, because that's what the trait requires of us. They all need to have this. But also we saw in the code that they, basically if they don't want the code to error if we're doing something that we can't do, it just is going to return something that's not very helpful. So in this case, it's just going to return itself. Which means that if you're in pending review and you request review, you're still going to be in the pending review state. All right, so then we implement approve. So similarly, we implement a version in post and we implement a version, or we require that we need to implement a version for state. And then similarly, we're creating we're not quite there yet, but we're creating an empty struct published that is going to be returned, that is representing the new state that also is going to implement state. So this is approved for pending review. And that gives us a published struct. Content is going to give us nothing by default. So this is, if you remember, we can do default functions for traits. So we don't necessarily need to implement this for everything. The other two functions, we want to just return an empty string. And so the only one that we need to implement it for is published. And in this case, we're finally ready to give the user the content because it's in the published state. Okay. So I thought I'd stop here and get you guys' opinions about this. I think it was interesting to read this implementation, and I could see, they make the argument before I show the enum stuff. They make the argument that it could be more code to do an enum to manage state. In this case, I assure you that it was not. But I could see it being for something like very intricate. I could see it being useful, but I don't feel that they picked the best example for it. I don't know. What did you guys think?
Yeah, I think it was kind of confusing generally. I think I just need to read through it again, and after hearing what you shared, and just try to work on a little more. It feels almost a little bit circular because you have these, I don't know. Oh, everything references everything else kind of thing.
It is a little circular. Yeah. Oh, I can't hear you. You're not muted.
Sorry, I forgot I turned my mic off. It seems like it could be more code, like you said, because you have all these default, all these extra functions you don't want to call ever, but you have to implement them anyway because they're part of the type, right? The trait.
Yeah.
So, and it seems like you forget to do that or whatever.
Yeah, it's interesting. One of their examples for the enums was that like in this case, we only have 3 states, so it's not that bad to match. And in fact, the only match I had to write could use the default catch to not match, but they said that anytime you use an enum, you have to write a full match statement for it. So it could get verbose that way, but in this case, it was not.
I guess it would depend on if you expect the number of states to be like growing. Like, oh, I might be adding new states at some point, and I don't want to go back through all those match statements. It'd be easier for me to. Right, when you add another one, it'd be easy enough to implement those methods and be done. Once you all have it all done, right? But it'd be hard to go through find all the places where there were match statements and make sure you got them all, right?
Yeah, that's true. That's true. I guess you wouldn't have to update much of anything.
Yeah.
If that wasn't directly changed. Yeah, that's interesting. So anyway, for this one, I have their exact same code. this was sort of like my test case, was that this should be able to run still. So my version of this with enums was that I had an enum that is post state, and it's draft, pending review, or published. So just like before, the new method gives us a post that doesn't have anything in it, but is in the draft state. Add text does exactly the same thing. And then we've got request, review, approve, and content. And so request, review, and content and approve are really not doing much now. They're using if let to check just like the one thing that's relevant, and changing the state if necessary, because we don't actually need to do anything else in this case, the way that they have their code written. If we're not changing the review state to pending review, we could just leave self state alone. We don't actually have to return that self state. So similarly, I did if let for approve. So if it's pending review, then we can change it to published. And then this is the single match statement that I had for it, which was, if it's published, then you can give it the content, and if not, then give an empty string. So in this particular case, it was like way less code and way more streamlined, I think. And it does work.
Seems to it's a lot easier kind of match, I think, into what we're trying to do, and like just say, hey, is this thing ready for review? Is it a draft, or like is it published? Like you just change the value, and it looks a little bit more like a like another like object oriented language.
I guess you could have used an if let else, right, too, and then avoided one more match, but I don't know if it would be cleaner or not. But
yeah, that's true. I think in this particular case it'd be roughly the same, but yeah, that's true. It's a backup.
Yeah. If you really wanted to say you had no match statements at all, despite what the book said,
yes, that's true. That's true. Yeah, if I really want to stick it to them. Yeah, I remember the first time I read this chapter. This is one of the reasons I picked this chapter to present on. This was I remember it being like, it didn't stick very well in my mind. So, but I think that this is why. So I don't know. I think it's still worth, the fact that it's still there as an example suggests to me that it's worth at least thinking about further. Although I don't know that I would ever use it. I like traits in general. Traits have won me over as an implementation tool, but yeah, doing it this way, I don't know. That has not won me over yet, but I think it's still worth considering. So short today. It was actually a pretty short chapter. I think that it just took longer to read that third part because I had to like reread sections of it to be like, wait, what's it doing now?
Thank you.